All right, this unit we are talking about transformations of functions, meaning we're going to do some things to move around graphs of different kinds of functions. Before we can move around graphs, we actually have to remember what we call the parent function. The parent function is like the basic graph that we change around using some function transformations that we'll talk about all unit. We have learned all of these basic functions, almost all of these basic functions throughout Algebra 1 and Algebra 2. So today's lesson is all about remembering what those functions look like so that you can identify them easily and use them when we are doing different tasks throughout this unit and especially on your project. So first we're going to start with a linear function. This is the very first function you learned about in Algebra 1. If I click down into this, the linear function is the y equals x function, or y equals mx plus b. I'm going to click this graph on, and you'll notice a linear function makes a straight line. So when you see a function that makes a straight line, that's our linear function. It's the y equals x function. One that's related to the linear function is what we call the absolute value. Absolute value is the distance of a number from 0. And we always measure distance as positive, so when you see this absolute value, that's those two vertical lines, you'll notice that it's kind of like a straight line that came down and bounced back up. And what's interesting here is that the distance from 1 to 1 is a positive 1, right? The distance from 1 to 0, is a positive 1. The distance from 0 to negative 1 is also 1 unit, which is why it's 1, 1. So my absolute value feature, the feature of this graph that's really prominent, is that it makes a V. The next kind of function I hope you remember from Algebra 1 and a little bit in Algebra 2 Unit 2, it's our quadratic function, y equals x squared, also known as a parabola. This is what a general quadratic function looks like. It looks like a U-shaped graph that has a maximum down here, and it is our nice quadratic parabola. Kind of related to quadratic functions are cubic functions. They are a higher order polynomial. So this is a second degree polynomial. A cubic function is a third degree polynomial. And this is characterized by a nice little squiggle through 0. Remember, it is an odd degree function, which means that the ends are going in opposite directions. And this is what our cubic function looks like. All right. Related to the cubic function is the square root function. It's the function that happens when we take the square root of x. I'm going to click back on and show you the quadratic function because quadratics and square roots are inverses. So you'll notice that a quadratic function is an upward opening U. A square root function is like we've taken that quadratic and it's kind of gone sideways. Interesting. We talked about this a little bit in Algebra 2, but our square root function starts at 0. We can't have any negative values under x, they would be imaginary. So that's why it's got to be only positive and increasing in this positive direction. Now, I'm going to throw back up the cubic function because when we talk about cube roots, that's the inverse of cubic. So our cubic function squiggles right through 0, goes up and down in opposite directions. Our cube root function squiggles, but it's sideways, kind of like the square root function went over to the right. The cube root function squiggles, and you can have negative and positive cube roots, which is why this is fine having negative and positive values. The next kind of function, oops, I made a mistake, is called a rational function. Rational functions have the word ratio in them, and when I hear the word ratio, it makes me think fraction. So a rational function, we're looking at two examples of a rational function, a fraction function, a ratio function. And those two examples are 1 over x and 1 over x squared. We looked at the 1 over x graph, and that's the graph that has two two curves that don't cross the x or y axis. Remember, there's a vertical asymptote at 0 and a horizontal asymptote at 0. So this is the 1 over x graph. The 1 over x squared graph looks similar to 1 over x. However, we know that x squared can only be positive. So the 1 over x squared graph only has positive y values. There's still a vertical asymptote at 0 because you can't do 1 over 0, right? That's undefined, so we have that asymptote. And we still have a horizontal asymptote at 0. But because it's 1 over x squared, all the values have to be positive up here in the positive y region. So these are my rational functions. You should be very familiar with exponential functions because we just finished a unit on them. I'm giving you a general form. I'm calling it y equals a to the x because a could be lots of different values. This is assuming that our growth factor is changing and that our initial value is 1. So another way of thinking about this is 1 times a to the x. That's like the basic version of an exponential function. We know that we can change the initial value in the growth factor, but for these purposes, we're going to keep the initial value 1. And you'll notice, as I change the growth factor, my exponential function changes. If I make it negative, it does something funky. But just assuming that it stays positive, we know that it's going to approach 0 on one end, and it's going to go up to infinity on the other end. This is my exponential function. Right after my exponential function is my log function. And remember, logs are inverses of exponential functions. So just like cubic and cube root, or quadratic and square root, kind of had some interesting properties. When I show you the log function, you'll notice, it's kind of like an exponential function, just sideways. So my log function, similar to the exponential, right? We can change the base. It's going to get very, very close. It's going to get to negative infinity down here, but it's not going to cross 0 because we can't have that negative value. We can't have negative inputs. We can't raise something to a power and get a negative number. And this is going to go on to infinity. So it kind of looks like an exponential function, a little bit tilted sideways. The last kind of function, are actually functions we have not talked about, but it's important to know what they are and that they exist. You don't really need to know anything other than their shape. We call these trigonometric functions. If you are in geometry right now, you've heard of sine and cosine because you've talked about them with triangles, but we don't really talk about trig functions too much and how they behave until we get to algebra, to precalculus. But just so you're aware, sine and cosine are your squiggly functions. Sine and cosine are very similar. The difference between the two is that sine kind of looks like a straight line through 0. It crosses through at 0, 0. Cosine, looks so similar, but instead of crossing through at 0, 0, it crosses through at 0, 1. But they're both very similar squiggly lines. It's just how they cross where their y-intercept is, that's a little bit different. So this has a y-intercept at the maximum. This one has a y-intercept in between the minimum and the maximum at 0, 0. So these are our basic parent functions, and you're going to be completing a Delta Math task now that's asking you to identify these parent functions. So make sure that you are paying attention. I will also provide a link so that you can see another version of this all laid out, but that's what you'll be practicing for now.